Okay, so this video is kind of a tie-in to factoring quadratics because one of the ways we can solve the quadratic equations is with factoring. And so when we say solve, you might notice that there's two variables involved, right? Where mainly you've only dealt with variables like there's only been one x and one y, correct? Now notice how on number 1 there's two different n's. There's 3n and then there's 4n. On number 2 there's m and then another m and m. And then there's multiple variables in here. And what we do is we factor to separate all of the variables out. Then we set each of them equal to 0 to solve each variable separately. Okay, so with quadratics, again, a normal quadratic equation looks like this. You can say 3x squared minus 4x plus 5, something like that. You'll notice how if there's x squared involved, okay, a quadratic equation will have two answers. Okay, quadratic equations will have two answers. So what we do is if we can solve by factoring, look at number 1, it's already factored for you, awesome. We just set each equation equal to 0. This is what we call the zero product property, because if I make one of these zeros, because when I have two parentheses like that, it's like a multiplying. If I only make one of the parentheses 0, 0 times anything is still 0. So I have two different ways to find out what my answers are, or there's two different answers to the question. So if I add 2 here, 3n equals 2, divide by 3, n equals 2/3. Awesome, that's one of my answers. If I subtract 1 from this one, I have 4n equals -1. Divide by 4, n equals -1/4. So both of these answers are correct. These are both places where my graph will equal 0. It will equal 0 at 2/3 and at -1/4. And it would make a lot more sense if you saw a picture of this graph, if I could kind of do a loose drawing, if you will. So a quadratic equation looks like a parabola. So for those of you who've never seen that before, it looks like a U. And the U would look something like this. Okay? Again, this is a very rough sketch of what it would look like. But what we're saying is, when we graph this out, is that there's two different places it crosses the x-axis. And those two different places are right here at -1/4 and right here at 2/3. Those are the two different places where my graph crosses the x-axis. And so that's what we're finding when we set each piece equal to 0. Okay? So let's try, I'm going to do a problem like it. Let's go back here. Here we go. Let's try number 3. All right, so taking a look at number 3. So I'm going to set each parenthesis equal to 0. 5n minus 1 equals 0, and n plus 1 equals 0. Okay, let's add 1 to both sides here. So 5n equals 1. Divide by 5. n equals 1/5. So that's one of my answers. Here we subtract 1. And n equals -1. So that's another one of my answers. So those would be the two places where my graph crosses the x-axis. Okay, number 4 is very similar, but taking a look at number 2, okay, this one's a little bit more tricky because you'll notice there's not two parentheses, there's only one. Okay, well obviously I know I can do m minus 3 equals 0. We can add 3 to both sides, and m equals 3. Okay, so that's one of my answers. But what about this m here? So the m in front, or the factor you took out, you still set that equal to 0. It doesn't matter, so m equals 0. And, wow, that's easy. There you go. Because if you think about it, right, if I plug in 0 for m, 0 times -3 is still 0. But if I plug in 3, it's going to be 3 times 0, which is 0. So both those answers are correct. So whatever you factor out or is on the outside of the parentheses, you also have to set that equal to 0. So this kind of gives you an introduction of how to solve equations while factoring. And I'll do another video with more complicated examples, but here's your intro.